Okay, so I'm going to go do that. There we go. Okay, so working with radicals, let's just take a look at this. First, you're going to simplify radicals, and I put here radicals. It's a huge part in geometry. You might think, well, why are we going to use radicals? It's a huge part in geometry. We're going to use them quite a bit throughout. Whenever we see a radical, we're going to need to simplify it, like this here. We need to know what to do with radicals if we have more than one radical, on how to maybe add them, put them together, multiply them, or something like that. That's why I have us going through this. We definitely are going to need to be able to know how to rationalize denominators when we're having a fraction with a radical at the bottom, so that's also going to be in here as well. So first of all, simplifying radicals. It says here, a simplified radical expression is said to be in simplest form when all three of the following statements are true. So here's 1 through 3. It says, first of all, the expression under the radical sign, which is called the radicand, so that would be like the 96 here, is called a radicand, and that one, it's under the radical sign, contains no perfect square factors other than 1. And that would be these guys over here on the side, our perfect square factors, other than 1, because 1, it doesn't really work. It doesn't really matter. You're not going to really use 1 ever. We really kind of start with using 2 and so on. So 1 can always come out of every number. So even this, could be 96 times 1 is, still a 2 factors that multiply to give you 96. But we don't really ever use that one because 1 doesn't really make any sense to use. Number 2, the radicand, again that number underneath the radical, doesn't contain a fraction. So you can't have any fractions under your square root. That's not simplified. And the last thing is the denominator does not contain a radical expression. And so that means if you have a fraction and maybe the top is not a radical, but the bottom is a radical, that's not simplified either. We're going to see those way down here at the bottom when we're dividing square roots. You can see that here. There's radicals at the bottom of those. Okay, so let's come back up here. I'm just going to do just a few of these just to give you kind of an idea of what to do, and then I'll let you work on the rest. So right now, we're just going to work on 1 through 12 on simplifying. So if you have your own sheet of paper, what you want to do is on the top, just put the title up here. You could just say Algebra Review 3, you could say Working with Radicals. Again, make sure you put your name, even if you print these pages off, put your name on every page that's printed off. If you're doing it on your own piece of paper, you may want to take a picture. I'll pause the video, or I'll just pause for a second here on this spot. If you want, or you have this, right? So you don't need to take a picture of this part. But you may want to write this down on your paper, but just so you know what this is, these 3 things that cause for simplifying radicals. And then over here, just go ahead and just make maybe number 1 square root of 96, and then you can also maybe divide your paper in half, fold it in half long ways, and then on the other side of that crease, go ahead and put number 2 square root of 216. I would leave 2 line spaces if you're doing it on your own piece of paper to give you enough space underneath, and then do the next row. 2 line spaces, do the next row, and so on, just to try to format it the same way as over here on this page. Alright, so here's what we need to do is I'm going to start, I'll look at number 1 first. So the square root of 96, how would we simplify that? And if you look through a whole list here, there's only one of these problems that you find over here on this list that will become a whole number. And if you can spot that right away, that's right here, number 6, square root of 144 is on our list. So that number, right away, you could know number 6 is the answer there is 12. It is a perfect square. 144 is a perfect square number. It is 12. So that's the only one that actually becomes a whole number. Every single one of these other ones is still going to be a radical, still going to have a radical in it. So the first thing we need to do is take the 96 now. It's not on our list. We can come over here and see that 96 is not on our list. But where would it be on the list? That's where we want to start. So 96 would be right here between 100 and 81. So we want to start working our way backwards at that point to see, okay, which one of these perfect squared numbers is going to go into 96. And we might need to use a calculator here at some point, so I want to make sure I have my calculator brought up. If I can get that here. Let's see. Where's my calculator? On there. It might be under the accessories. I had a button somewhere that had it. That's right. Accessories, calculator. Okay. So let me just get that down below so I have it ready. So the square root of 96, we're at 96 here. So I'm going to start working my way backwards. Does 81 go into 96? No. Does 64? No, it's still too big. 49, okay, at that point maybe 49 might go into 96. You know, and you can at that point try it down here on your calculator. You could say, okay, so 96 divided by 49, does that go evenly? And you could say, well, no, it doesn't. So we're not going to use 96. We're looking for the biggest perfect square factor we can find. That's going to be here. So not that one, 36. Maybe 36 goes into 96. And you might know for sure just without doing the calculator, but I'll just show you on the calculator that for this one, 36 does not go into 96. Can't use that one either. 25, I know for sure 25 does not go into 96. 16 would be my next one. So does 16 go into 96? So I'm going to divide by 16. And yes, it does, 6 times. So that's the one I want to use, even though I can go down further, and I know 4 also goes into 96, but I want to use the biggest perfect square. That's why I'm working my way backwards down the row, finding the biggest one that's going to go in. So 16 does. So what I'm going to do here on this one is going to you can do it right next to it here. So I'm going to change this here into 2 square roots, one with 16, and the other one with 16 goes into 96. How many times? We saw in our calculator it was 6. So the 16 and the 6. 16 times 6 gives us 96. So now I can simplify, since 16 is a perfect square, it can be reduced to 4. So that's going to change to a 4, and this square root of 6 will stay what it is. And there's our answer, 4 square root of 6. That's our answer on that one. Let's take a look at another couple on here. I'll do maybe one a little bit bigger. Let's try number 8 down here, 175. So for 175, that's going to take us on our list all the way down here, right between 13 and 14. So we know 169 is not going to go into 170. That's too close. 144, no. 121, no. Still probably too big. 100 is not going to 175. 81. So now we might be getting into in the territory where it might be going in, possibly. 81 doesn't go in. I'm just going to show you which one does. 64 does not. You could try these on the calculator. The one that does go in is 25. 25 goes into a 175. We can do that on the calculator to find out how many times if you want to, or you can just know that. I do know that myself, but just to show you here, you can use the calculator 7 times. Now what you want to make sure of 7, just to make sure you got the biggest perfect square, that you didn't miss one that was bigger, is that 7, there's no more perfect squares that could go into 7. So 7 would take you right here between 9 and 4. So 4 does not go into 7. So because 4 doesn't go into 7, then we know that 25 was the best one. So we'll go ahead and write that down. Changing square root of 75 now into 2 more square roots. One with the 25, that perfect square root one, and what was left over was 7. It went in 7 times. So the 25 and the 7. So now 25, that changes to 5, and then the 7 just stays the square root of 7. So 5 squared of 7 is the answer for that one. Now these bottom two already have a number in front, and then it has a 96. I'm not going to do the 96 one because I already kind of did that up there, but I'll do this one, number 12. Let's do number 12 together. So we got to start with the square root, and then when we do this part, like when we found out that this one, the square root of 25, was a perfect square, and that turns into a 5, the number that's now here, 9, will multiply that number. So when we get that number out of this one, then definitely we'll multiply it by that 9. So 245, that takes us down to about here. So let's see, 15 does, or on this one, does 225 go into 245? No, it's too big. 296, no. Now since this does end in a 5, we're probably going to have to maybe even go all the way back down to 25 again, maybe, but not really, because it's not going to work either. That doesn't go in. So we're going to have to find something else that's going to go into 245. We're going to need definitely probably use the calculator for this one. So these guys are probably a little too big. 144, it's getting a little closer, but probably not. Let's try 121. It's pretty close. It's 245 divided by 121. We could try that and see. Whoops, I missed that one. 245 divided by 121. That doesn't go in, no. Let's try another one. 100. We definitely know 100 doesn't go in. 81 might. So 245 divided by 81. Does that one? No, it doesn't go in. 64. Probably not 64 because it ends in a 4 there. So that's going to always be probably an even number, and this one ends in a 5. So I wouldn't think that one. 49 might. So 245 divided by 49. That one does 5 times. There it is. So that's the number we want. So let's go ahead and use that one. Whoops. I messed up here somehow. Not sure what happened. Hold on here. What happened to this? Let me come out of here. Yeah. Let's go out of that. What's going on here? I think maybe somebody else might be presenting. Is that it? Not sure. Let's see. Cancel the print. Is there a print thing I tried to do? Let's see. Come over here. Yeah, there it is. Okay. Cancel. There he goes. Okay. Thank you. Not sure what happened there. I must have messed up. I need to move this out of the way. So I think that's the problem. My mouse and my other things can be tripped up. Okay, so back to here. Here. There we go. Okay, so what did we say? 20, what was it, 49? Let me bring this back up. Yeah, it was 49, went in 5 times. So that's what we want to use, 49 and 5 on this one. So we're just going to bring the 9 over right now, and that's going to multiply the number we get out here. We'll multiply that times we got a 49 there, and then we have another one, which was 5. And there's no more perfect squares. Obviously, 5 would be here. 4 doesn't go into 5, so that's done. So 49, that turns into a 7. Square root of 49 is 7. That's what it turns into. So now we have 9 times 7 with the square root of 5 next to it. So that's going to multiply 9 times 7. That's 63. So our answer for this one's going to be 63 and the square root of 5 next to it. That's our answer for that guy. Okay, so I'm going to go ahead and pause this right now, in fact. And I'm going to pause the recording part of it. There we go. Okay, so we're back to here again. So I did 6 squared is 6 for 2. 3 is 7, and then what's left over there will be 2. 49 goes into 98 2 times, so that's left over. That stays underneath the square root sign. It's a 2 in there. For 18, now we're a little smaller here. What goes in 18 is 9, so that turns into a 3. So our whole number is 3 on the outside. What's left over? Well, 9 goes into 18 2 times, so that's going to be a 2 left over. 72, if you look through your list here, the biggest square that goes into 72 is 36. 36 goes into 72 2 times. So the square root of 36 would be 6. So this is going to be 6 square root of 2. 2 is left over. 36 times 2 is a 72. This one we said earlier was just the whole number 12. It was that one right there. So this one has no more radical with it. So if it is a perfect square, then it's just the whole number. 45. This one, 9 goes into 45 here, so square root of 9 is 3. So this one's going to first have a 3, and then what's left over? 9 times 5. So 5 is left over on that one. And then I did number 8 already. Number 9. So with 9, what goes into 9 here is you keep on working through. This one might take you a little bit more time, but you should have eventually gotten to 49. So that one does work out there. I'll just show you on the calculator. That's what you would have needed and gotten to with 343 divided by 49. That perfect square right there is a 7. And so that comes out to be the one you want. So over here we're going to have the square root of 49 is the number 7. So your whole number is 7 on the outside. And it went in 7 times, so 7 is still inside the radical. And this one should be a fairly easy one. 4 times 3 is 12. 4 is the square root here. That's the one you want to go to. So even 12, you can see, well, 9 doesn't go into 12. 4 goes into 12. So 4 times 3, and the square root of 4 is 2. So this one's going to equal 2 for the whole number, and then 3 is the leftover part. And then for this one, we got to do the 96, which was already done for us up here. So really, you have this part already done. So you knew 4 was on the outside. So really, it's going to be 10 times 4 times the square root of 6. And so a 10 times 4 is 40. So this one here is just 40 and the square root of 6. Alright, so let's move on now to the adding and subtracting part. This one actually should go fairly quickly, I think. Alright, so I'm going to move off of all of that. Hopefully you got that down, you checked your answers. If you missed one, just fix it. And let's come down here, adding and subtracting square roots. So when we're adding and subtracting square roots, like you can see a square root here minus another square root here, what we need to remember here is you can only add or subtract if the radicands, and that's the numbers underneath the radicals, are the same. So you can see right here, they're both square root of 6, so we can add these together. But if they're not the same, like we can see down here, a couple of them, like 24 and 2 are not the same, or 5 and 2 here are not the same, we cannot add or subtract those together. They would stay separate. We can maybe adjust them so that they can become the same. That's the only thing we can maybe do. So with this, what we want to do is if the radicands are not the same, you might be able to simplify one or all to make them the same. So we might be able to simplify radicals individually, making them all the same radicands, and then being able to put them all together. Once the radicands are the same, you simply just have to add the coefficients and then leave the like radicand. So for number 1, we'll do this one together here. It's got the square root of 6 here. That's the like radicand, and that's simplified. There's nothing else you can do with 6. 4 is the only thing that maybe you could, but 4 doesn't go into it. So your answer is going to have the square root of 6. That's going to stay in your answer. What we're going to do is just put together this part right here. We're going to combine or add or subtract the coefficients. That's the numbers in front here. So negative 5. So basically we have this. You can just say negative 5 minus 2. I'll put that in a parenthesis. That's what we have to do here, the operation. And then we're just going to have a square root of 6 at the end of this. So this here, since negative 5 minus 2 is negative 7, we're going to see negative 7 square root of 6 as our answer for that one. I'll come down and do number 6. All these other ones have like radicals. Number 6 here. I'll do this one just because it doesn't look like there's any coefficient in front of this one. But we need to remember whenever there's not a number here, it has a negative sign. This really is a negative 1. So what this is going to be in fact, I should have raised this up a little bit before I started writing. That's okay. This is going to be negative 1. I'll put in a parenthesis like before, minus 2. And then you still have the square root of 6. Keep that the same. So negative 1 minus 2, that's going to become a negative 3, just using our integer rules. So the answer for this one is a negative 3 with a square root of 6. Let me come down. I'm going to do number 10 down here. So that way you can see one that's done that's not with the like radicals. So if we're able to, put some together, Now 2 and 5, there's no way I can simplify a square root of 2 or a square root of 5 any further. But square root of 45 I can reduce some because 9 goes into that and 9's a perfect square. So I can do that one. So I'm going to just keep my negative 3 here. And this one's going to become the square root of 9 and then a square root of 5. Well, the square root of 9 is 3. So I'm going to say, okay, I got negative 3 times 3 with the square root of 5. That's just this first part like we were doing before. Just trying to get that to where it's supposed to be. So that's going to give us a negative 9 now. So negative 9 square root of 5. And then I have this other minus square root of 5. So those are like radicals now. Plus 2 square root of 2. That one's the only one that's not the like radical. So I'm going to put together these two right here. And so this is a negative 9 minus 1. Remember, this would be a 1 in front. Negative 9 minus 1 is negative 10. So really my answer for this one, I'm going to put it out over here, negative 10 square root of 5, because we can combine those two. They're like radicals. But this one right here is just going to have to stay separate, plus 2 square root of 2. That's going to have to stay separate. That's what our answer would be here for number 10. So you have two radicals actually as your answer, because we can't put them together. They don't have like radicals. So you have your negative 10 square root of 5 plus 2 square root of 2. Alright, so I'm going to give you just a couple minutes here, just a few minutes, while I'm taking attendance. I'm going to work on the attendance at this point, and you can try to finish these ones only right now. Just go from 1 through 9, finish up 1 through 9 here, and then I'll show you the answers. Record again. Okay, so number 1 we did. Number 2, like radical there is square root of 5. So that should be in our answer. That part anyways. And we just have to put these two, so negative 3 and a positive 2 is negative 1. Now you may have written it like this, negative 1 square root of 5, but the better way to write that, remember we don't usually write 1, in fact like you can see it right here, 1 was not written, just the negative sign. So the better way to write this answer would just be a negative square root of 5. That's the best way. Yes? Oh, sorry, thank you for telling me. Let me go fix that. Sorry about that. There we go. And now I can go back to where I was here and here. Okay, so now you can see number 2 there. The answer to that, like I said, you may have put down a negative 1, but the better way to write it would just be just negative square root of 5. And then for number 3, you got just the same thing here, because you're going to basically have a negative 4 and a positive 3. When you put those together, that's a negative 1. So the answer for this one is going to be just a negative square root of 3. Number 4, here you have a negative 3 and a negative 4. That makes negative 7. And then you have your square root of 6 next to it. So that's it for that one. Here you have a negative 4 and a positive 5. So there's more positives here, which means the answer of that one with the number integers is just a positive 1. Now if you had done this, 1 square root of 10, that's not necessarily wrong, but that's not the best way to write it. The simplest way to write it is just the square root of 10. We don't need that 1 in front of that. So the best way is just the square root of 10. We already got 6 done. Here, again, this is a negative 1 in front of here, so negative 1, negative 5 would be negative 6. And then you have your square root of 7, which is the like radical. Again, same thing here, you have a negative 1 in front there, so negative 1, negative 5, another negative 6, with a square root of 10. Now, 10's getting a little large there, but that's still, you can't simplify the square root of 10 anymore. If you could, you would need to. So, you can think, well, 9 doesn't go into that, because 9's a perfect square number. 4 doesn't go into 10. So those two numbers, since they don't go into 10, you can't simplify the square root of 10 anymore. If this happened to have been a 12, for instance, then we would want to still continue to simplify our answer, because 4 could go into 12, and that means that you can make your radical smaller. And then this last one here, we have like radicals already right here. We can put these two together, but here's when we do need to simplify the square root of 24. So that is not as simple as that one could be. So we do need to simplify this part, and then we need to put together these two parts here. So when we do that, we can do them separately if we want to. When I simplify this one, square root of 24, I'm just going to put it right above here. 4 goes into this one. So that's the one that goes into it. 4 times 6. So that's going to be square root of 4 and then a square root of 6. That becomes 2. And so we're going to basically see a negative 3, still in front of this. Negative 3 times 2, I'll just do that right now in my head, is a negative 6. So for that one we're going to see yeah, I think I wrote it down wrong there. So yeah, so we got to see 24, 4 times 6. This becomes 2. So 2 times negative 3 is negative 6 with a square root of 6. That's the first part. Second part, we put these together since they're like radicals. Negative 3 and a 2, since that's more negative, we're just going to say minus. We don't need to say the 1. We can just say a square root of 2. So it's just going to be answer here, negative 6 square root of 6 minus a square root of 2. Alright, so let's move on to the next section, multiplying our radicals. Coming down here, multiplying. So multiplying is a little bit different. It shows you what to do up on top there. It says when you do not have to have like radicands to multiply or divide. So even though we do have some that are the same here, these are likes, they don't have to be. Over here on 2, they're not. 10 and 2, we can still multiply. So multiplying, as long as it's under a radical sign, you can multiply what's underneath a radical sign together to simplify into one radical. Because we have 2 right now in all of these. You're going to put them together to be one radical just by multiplying. And so same thing with kind of dividing as well. We can divide. They don't have to be like radicals to divide either. The difference though when we get to dividing is we're going to need to talk about this thing called rationalizing. So we'll do that when I get to dividing, but let's just go ahead and multiply right now. This should go pretty quickly. And when we multiply, we also need to keep in mind that we still have to simplify. So I'll do a couple of these here with you. So number 1, let's just take a look at that. So we can do 5 times 5, simplify it first to a single radical, with 5 times 5 being 25. But now I can reduce that. That's one of our perfect squares. We know that one's just going to become 5 only. So my answer for this one is just 5 only. But then when I come over here and do, I'll come down and do number 6. For number 6, we can get it to a single radical first. So 5 times 12, that's going to give me 60 when I multiply them. Okay, so on this one I need to reduce the radical, go back to my list. Okay, you can scroll back up and look at that list again, or you can scroll down a little bit and look at the list. And I'll do that. I'll scroll down here. Let's see if I can. Yeah. So I scroll down. Here's my 60. Where does that put me? It's right kind of right in there. So what goes into 60? 36 does not. 25 does not. 16. No. 16 doesn't even go into 60. 9, 4. 4 is really the only one that goes into 60. And if you back up here, so 4 goes into 60. If you divide 60 by 4, that's 15. So we're going to use 4, square root of 4, and a square root of 15. So I'm going to break it into those two radicals to simplify to get my perfect square one here. So that way I can see this one is going to be 2 with a square root of 15. There's my answer for this one, 2 radical 15. So that's our answer here on that guy for number 6. 2 square root of 15. So even though you want to get it to a single radical, you need to realize you need to make sure that radical becomes simplified if it can be. It might not be able to be, but if it can be, you want to. I think most of these you will be able to simplify. Let's do one of these down here, since it has a number also in front of these. I'll go ahead and do number 9 down here with the negative sign. So when we're doing these, we're going to multiply also what's in front. So what's in front of this one is a 1. 1 times negative 2 is negative 2 for your front number. And then you're going to multiply the radicals as well. 6 times a 6, then we give you 36 for that guy right there. And so now we want to reduce this down to negative 2, that comes down, times the square root of 36 actually is just a 6, so this just becomes negative 12 for that one. I'll even do maybe up here number 8, so you can see one of these done as well. Actually, no, I'll do number 7 over here. You can do 8. So 7, with this one, 2 times 1, there's your whole numbers on the outside. 2 times 1 is going to give you 2. And then 2 times 12 for the underneath numbers is 24. And so now we need to reduce this part here. And we'll have our 2 still in front. And that's going to be times the square root of, let's see, for 24, the perfect square that goes into it is 4 times 6. 4 with 6 left over. So this becomes 2. So now we're going to see it's going to end up being 2 times 2 times the square root of 6. And so 2 times 2 is 4. So our answer for this one is going to be 4 square root of 6. So there's our answer for number 7. Alright, so go ahead and finish the rest of these that I didn't do. And I'll show you the answers here in just a minute. Doing this one anymore. Okay, so number 2. Answer for number 2, that would have been square root of 20, and you want to simplify square root of 20 because 4 times 5 is 20, so that becomes a 2 square root of 5 for an answer. These guys are easy right here. This is becoming square root of 64, which is just 8. It's the number that's underneath there. Same thing here, I'll just even do 5 again. It's just like it. This one's 3 because that's the square root of 9. That's a 3. Those are just easy numbers like it was on number 1. This one becomes 200 on the square root sign. So the square root of 200, well, that's 100 times 2. 100 is a perfect square. So that becomes 10 square root of 2 for an answer. Because you have the 100 times 2, and the square root of 100 turns into 10, and then you have the square root of 2 still. We got 6 done and 7 done. 8 and 10 are actually very similar. Again, you have a 1 here in front. 1 times 2 is going to give you 2. And then you have 5 times 2 underneath the radical, that's the 10. So square root of 10, you can't simplify that anymore. You're done there with 2 square root of 10. This one also has a 1 here, but this is now just a negative 2. Same radical though, 2 times 5 gives you another 10 there. So those were very similar. This one's just a positive 2, this one's just a negative 2. Okay, so hopefully you did fine on those. Those should be fairly easy. Now dividing, these ones are a little more challenging because we have to talk about rationalizing. So when we rationalize, that's what this is. Rationalize simply means that the denominator has to be a rational number, which means it cannot be a radical anymore, because radicals are not rational numbers. There are certain types of numbers. We talk about real numbers, we talk about integers, whole numbers, and those kind of things. Well, there's rational and irrational numbers, and an irrational number is a square root. A rational number is just not a square root anymore. So we need to make sure when we're coming down here to do dividing that all of these bottom ones are not going to have any radical in it anymore. So they do have a radical on top though, so we can do this first. So like on this one, for instance, number 1, I can do this. I can say make this one big square root, and now I just have 3 over 48 like that. And I can simplify. Does 3 go into 48? And it does. 3 goes into 48. If you look at your calculator, it goes in 16 times. So now I can reduce this now to being the square root of 3. In fact, I don't even need to do this part, and I don't usually do it. You can do it this way, but I don't usually try to do it that way. I just kind of reduce it because these are both underneath. I can kind of reduce. So 3 goes into 3 one time, so this becomes square root of 1, which is 1. So we've got a square root of 1 on top. I mean, don't forget these are still under square roots. And then 3 goes into 48 16 times. I'm going to say square root of 16 is there. So now you just want to make sure that you can, whatever's perfect squares can come out. So square root of 1 is 1, and the square root of 16 is 4. There's our answer. That's fine. That is our answer to 1/4. Now the problem will remain is if the denominator will not come out to be a whole number, that means that's when you have to rationalize it. So let me see if I can find one that will do that. I'm not sure if there's going to be one that does that. I think maybe 8 over here is going to do that, or this one, number 6. So let me do number 6 with you. So for number 6, 6 and 8, yeah, they both can reduce. We can reduce these. 2 goes into both of them. So I can start by reducing this to a square root of 3, right? Because 2 goes into 6 3 times. And this would be square root of 4. Now, that still doesn't work there on that one either. I was hoping to get some rationalizing denominator ones here, and I didn't. Yeah, I think all of these are going to eventually come out to be just fine. So these are going to be fairly easy to do on this one. I'm going to have to give you some a little later, maybe with rationalizing denominator. So I'm going to have you go ahead and try these, just like this one and this one here. This would become the square root of 3 on top, which is fine. It's fine that that stays a square root. This is going to be 2 on the bottom. That's where we need this to be a whole number. So that's a fine answer. It's okay to have a square root left on the top. You just can't have the square root left on the bottom. So try the other 4 here, just like that. And I'll give you the answers, and then I'll try to show you one that does have a rationalizing situation. Okay, so for number 2, this one, you can just see 4 goes into 12 right there. That really just cancels this whole thing out. You don't even have any more radical. That just becomes square root of 3 then. And you're done. That was the answer for that one. Now on this one, 5 goes into 20 right here 4 times. And so they have a square root of 4 left on that one. And you don't have any fraction anymore. That's completely gone. And so that's just going to end up being 2 for number 3. The answer is just a 2. With this one, you can reduce this by 4. 4 goes into 125 times, and 4 goes into here 2 times. So we're going to see it's going to be a square root of 2 still on the top, and the square root of 25 is 5 on the bottom. So square root of 2 over a 5. And this one, 5 goes into both of these. So 5 goes into 15 3 times, and this one, 5 goes there 25 times. And so our answer here is going to have the square root of 3 on top, and then the square root of 25 is a 5 there. Okay, so for number 7 and 8, I'll do a different color. So 7, I'm going to have us write down, just copy this one down, 3 over a square root of 5. It's 3 over a square root of 5. So already, right now, there's nothing I can do with a square root of 5. I can't get it to become a whole number. So what we have to do for this is rationalize it. So to rationalize it, I need to multiply this by a form of 1 where it's a square root over a square root. So anything over itself is always equal to 1, and you can multiply by 1 anytime to anything. So what I need to do is figure out what do I need to multiply 5 by to get a perfect square, and that is just the number itself times a 5. 5 times 5 is 25. That would give me the square root of 25 like we saw before. So square root of 5 over square root of 5 here. Now I just multiply the top, and so that becomes 3 times the square root of 5 on top, and now I have the square root of 25 on the bottom, and so I can just simplify that real quick now, so I can now have this rational. So my answer for this one would be 3 square root of 5 over a 5. Now I can't reduce the 5's there because this one's under a radical and this one's not, so that is as far as I can go with that one. It's a good answer because the bottom does not have a radical anymore. Alright, just one more, and then we'll be done with this. Number 8. Go ahead and write this one down for number 8. We wanted it in blue. So this is number 8. I'm going to put 2 over a square root of 8. So on this one, I could multiply, again, I got to multiply by a square root over a square root. The number has to be the same under there. I could make it an 8, but what I want to try to do is make it the smallest perfect square I can possibly make it, so I don't have any more simplifying that I would have to do. So I can see, what does 8 go into out of our perfect squares here? Well, 8 does go into 16, I can multiply 8 times 2 to get a 16, so I just need to multiply 2 up there. So 2 times the square root of 2 for my top part, and then 8 times 2 is 16, so I have a square root of 16 now there. And so my top part stays the same, 2 square root of 2, and then 16 here is going to give me 4. All right, so now here's where I can reduce it a little bit more because the numbers that are outside, the 2 up on top here are outside and the 4 can reduce. So I can change that into a 1 and change this one into a 2. So the final answer for this one would end up being 2 over, actually I should say square root of 2 over 2 on this one. So that's my final answer on this number 8 problem. Okay, so I'm going to go ahead and stop recording. I know we're just out of time now, but let me just